Okay. Hi. So my name is Daniel Vrátil. I'm a okay. So I have to wait for another 6 seconds. So hello, my name is Daniel Vrátil. I'm a long-time KDE developer and Qt user. And today I want to talk to you about Qt, or even more about QML, the Qt modeling language. The talk is not really about teaching you QML, although it's a developer conference, so I do have a few slides with code. The main purpose of this talk is to actually show you what QML can do for you, how you can use it, and what really cool features it has. So hopefully after this talk, you will, well, maybe at least consider QML for your next project, or maybe even for your current project. And we will know what Qt and QML can offer you. So when QML first appeared, I was really skeptical about the language, because I thought, like, well, why would anyone want to use this weird new scripting language instead of using the glorious C++ API for widgets, right? And so I stick to classic API C++. Eventually, though, I got a project which was using QML, and so I opened the QML file and immediately saw the code. I saw where the problem is, and I could fix it in like 5 minutes without even seeing the code ever before. And at that point, I realized I was so wrong about QML. QML is really simple, and it's so powerful that anyone basically can use it. And yeah, since then, I'm using QML a lot. So let's begin with actually look a bit into Qt. I suppose most of you, or all of you here, at least heard about Qt in the past. Qt is a cross-platform open source application framework. I will just briefly go through a history and something about licensing of Qt. So this is a very brief history of Qt. It started in 1995, developed by a couple guys in Norway. The important milestone was KDE, which is using Qt, right? It was released in 1998. I will talk about it on the next slide a bit. Then a couple more releases. In 2008, Qt or Trolltech, the company behind Qt, was acquired by Nokia. So Nokia actually back then had a plan to use Qt and QML, or only Qt back then. It was Qt on their Symbian systems and on the smartphones. And in 2010, with Qt 4.7, they introduced QML. So QML was actually developed by Nokia. They wanted to have something that is way easier than C++ to create user interfaces, mostly for mobiles, but it also works very well on desktop. In 2012, Nokia realized that's not the way they want to go. They sold Qt to a company called Digia. Nowadays, Qt is owned by Digia subsidiary called the Qt Company, surprisingly. And yeah, in 2012, the same year, Qt 5.0 was released, and nowadays we have Qt 5.5, with 5.6 being released, I think, in March this year. One thing that people usually know about Qt is that there was a sort of a license controversy about it, because the first releases of Qt were not really free, as in free speech, or they were not really GPL compatible, right? The first two releases were available under FreeQt and QPL, so the custom licenses not really compatible with GPL, which was even one of the reasons why GNOME was started, right, as a project to actually have a desktop environment based on really open toolkit, which was GTK. There is a foundation called KDE Free Qt Foundation, which actually assures that whatever happens to Qt, or the company that owns Qt, whether they are acquired or they go bankrupt or whatever happens, that Qt will always be available under a proper free license. So nowadays, Qt is available under GPL v2, GPL v3, and LGPL. In the next release, sorry, that's supposed to be Qt 5.7 release, not 5.6. There will be also LGPL v3 available. So yeah, Qt is now properly open source project with open governance and everything. Now, Qt, I said, is a cross-platform toolkit, and cross-platform doesn't really mean Linux, Windows, and Mac. Qt can run really anywhere. Obviously, the Linux, Windows, and Mac are supported, but you can also get Qt on Android, Qt on iOS, Qt for Windows Phone, QNX, that's BlackBerry, and a couple more embedded systems. So you can really get Qt on any platform you reasonably may want to target, right? On Linux, obviously X11 and Wayland are supported just out of the box. Qt also supports some frame buffer backends, so you can even use it on embedded. What is a great thing about Qt, and one of the most powerful parts, is that it is a platform-native look, which means that if you run a Qt application on Windows, it actually looks like a Windows application. If you run the same code, the same application, just compiled for Mac, it will look like a native Mac application. On Linux, we have KDE has their own style, like a plugin that slightly changes the default style of Qt. Currently, there is a project called QGNOME platform, I think, right? Which basically creates, which basically is a plugin that makes attempts to make Qt applications look native in GNOME. So you start a Qt application in GNOME, and it will look like a GTK application. So you can really, and if you are targeting another platform or you want to have a specific look, you can just write this plugin yourself. So then you can create your custom look and feel packages very easily, and it can also affect your QML code. We will show that later. So this is an example of the Qt Designer on Windows. Qt Designer is the tool where you can just click and create UI. This is how it looks on Mac. So you can see that this looks like basically a native application, and that's without any piece of changes to the code of the project. So nowadays, Qt is really everywhere. It's not just your computers, but phones, televisions, coffee machines, fridges. Qt's everywhere. You don't see it because it's usually you cannot even tell that it's Qt because the looks is customized and everything. But really, Qt is everywhere. So if you have a project where you want to target more than just Linux, then Qt is a really great choice for that. So now to finally speak about QML a bit. So QML is a declarative language. Declarative means that unlike with C++, where you would just say, in sort of commands, do this, do this, do this, do this, in QML you actually describe the entire thing in a declarative way, right? So you just describe the hierarchy of the objects, how they are nested, what are the properties, and how you describe it, that's exactly what you get on the screen later on, right? So it's really easy, and because it's a scripting language, you can actually, well, you don't need to recompile everything, right? When you change something, you just restart the QML viewer and you see the change. So it's really great for quickly prototyping the UI because you don't have to, just try to change this one, make it 1 pixel wider, recompile everything, run it again. In QML, you just change it, reload the file, and you're done. One important note, when sometimes this is being confused for historical reasons when the separation wasn't like that, but QML really is just language, right? When I say QML, I really mean just the language, nothing else. The language on its own cannot do anything, right? It's just a syntax. In order to be able to instantiate some objects in the QML, you need some components, right? And there is a set of components or a module called QtQuick, which contains the basic simple components like rectangles, some scrollables, and this stuff. But you need to import it first, right? Without that, you have a cool language, but nothing to create in that language. There are more modules of components, obviously. So you have QtQuick is the default one, shipped with Qt. Qt also offers QtQuick controls, which are the actual widgets like buttons, checkboxes, radio buttons, and this stuff. And then there's QtQuick layouts, which provides layout for the controls. There are some graphical effect modules, which provides a fancy graphical effects. Or you can just create your own, right? You can just write your own module, usually in C++, but you can also create a module just by putting a bunch of QML files together and saying this is a module, and you install it into the Qt directory. And then from your QML code, you can just say import, my module, and QML will import your module and make the components that you created there available in the QML file. Speaking of the plugins, another great thing about QML is that it's extensible. It's extensible through C++, which is not that great if you want to avoid C++, but still. So as I said, you can. Yeah. So there was a comment that there are also bindings available, like for Python, so you can actually create plugins in Python as well, and maybe other languages. I think I remember there was other Ruby bindings, right? But Go, yeah. Anyway, yeah. So let's focus primarily on the C++ plugin, but obviously it will apply on the other languages as well. So you can imagine you have your huge application, like let's say a video editor. So obviously you don't want to implement your logic in QML or JavaScript, right? That you just don't want to do that. So what you do is you write a bunch of C++ classes that implement the actual logic, right? The business logic of your application, and then you export them as a plugin. So you can have a model which gives you access to the files. You can have some sort of a timeline which shows you the videos you are editing and stuff like that, implementing it in C++. And you create this as a C++ plugin that you install with your application to the system. And then from your QML, you really just import this module, and you immediately have these objects available. So in QML, you just create a list view, and then you attach the model that you actually created in C++ to the list view in QML. This means that QML, being a different language than C++, it enforces you to keep your UI and logic separated. The separation is very strict, right? Because these are two different languages. So you look at it and you clearly see the border. When you are writing your UI or when you are implementing an application using the normal Qt widgets in C++, you can try, or you will obviously try to keep your UI and logic separated. But since it's the same language, eventually your logic starts bleeding into UI and vice versa. With QML, it's really easy to do the separation, right? Because they are different languages. So the approach is to actually. So the question is, how do you then get your logic connected to the UI, right? So one of the possibilities is the plugins that I mentioned. The other possibility is that you actually have a C++ application that instead of a normal window creates a QML window and loads a QML file, and then it basically instantiates all of your application logic objects, controllers, whatever, and then injects them into the QML context, basically as global variables. So you can reference them from the QML and access them like if they were pointers in C++. I will not probably show or talk too much about the UI, about the C++ integration late in this talk, but yeah, it's definitely possible and it's used a lot. But it's also possible to create pure QML applications, right? QML is using JavaScript for basically to also provide some non-declarative, some imperative programming or way to, because not everything can be expressed with the declarative approach, right? Sometimes you need that bit of imperative programming when you say, well, do this, and it somehow affects the UI, but mostly you are okay with just the declarative approach. So QML is so awesome, I actually use it to write slides. And to create this abomination took me like 15 minutes, right? So, and there's like, I don't know, 6 things happening at the same time. And this is all real, like, I don't know, maybe 100 lines of code in the slides, right? So yeah, QML is easy. And now, okay. Now, since this is a developer conference, I need to show you some code. But I really just want to explain how the basics work, right? We won't go into the deep details. Although after this couple slides, you actually will be able to write a simple QML application because it's really easy. So in this piece of code, we actually create a blue rectangle. The syntax is very intuitive. If you ever saw any programming at all, you get the idea of what's going on. So on the first line, we just import the QtQuick. So we need to tell QML which module of components it should import so that I make it available, right? Because as I said, QML is just a language. There are no components, no rectangles, nothing. So we import QtQuick, which contains, among other things, the rectangle. And then on the next line, we just say rectangle and curly braces, and that's it. This way we tell QML, please create an instance of rectangle. And then we use the JSON-like syntax to just set a couple properties. So we set x, y, width, height, and color. And what we get is a blue rectangle. Yay. Now, you can also create your own, extend the object by adding your own properties, right? But that's I will not go into it here, but it's possible to have your own properties added to it, and then all the things that I will show later apply to these properties as well. Now, a question, like, what if we want to put another rectangle inside of this rectangle, right? For instance, what if we want to put a red rectangle into the blue rectangle? Well, it's easy. We just put another rectangle into the rectangle in the code as well, right? So we just nest another rectangle into the blue one, and magic happens. It also shows inside on the screen. There are a few things that you might notice. The blue rectangle is the same as on the previous slide. In the red rectangle, in the nested one, you might notice a couple weird things. First is that we don't use any absolute positioning, right? The geometry of the red rectangle is relative to the parent. So in the x and y properties, I use parent.width. The parent is sort of a magical variable that just refers to parent. So in this case, it refers to the blue rectangle. And I do some math to put it in the center. For the width and height, I just refer to the blue rectangle explicitly, right, using the ID property. This allows me to, using the explicit reference, the explicit name allows me to reference any other object in the hierarchy, right? In this case, I only have one other object, but if there was, much more complicated tree, I could refer any other object in the tree using the ID. Now, what you might also notice is that I'm referring the width of the red rectangle before I actually assign to it, right? So on the line, well, for the x, right, I say width, like the width of the red rectangle. But I only initialize the width a couple lines later. So how is this not an error? Well, the properties are defined in the object, in the module that we imported. So the rectangle has defined a bunch of properties, including the width, height, and others. So by default, they just have some default value, like 0. So in this case, I'm just saying, well, take parent width minus 0 divided by 2. So then the red rectangle should probably be off-center, right? Because the math doesn't work yet. The width is not yet initialized. Well, the great thing about QML, and this is one of the most powerful parts of QML, is something that these are not just simple expressions. These are also called bindings. The expressions can be any JavaScript expression that you want, right? It doesn't have to be this simple math. It can be something way more complicated. It can be a function call. You can have if, then, any complex expression, and it's just about the return value of the expression, right? That's what gets assigned to the property. So in this case, a binding means that when I'm referring to some property in the expression, QML remembers that. And whenever that property changes, the QML will automatically evaluate all these expressions that somehow refer to it again and update the value, update the result, right? So yeah, when this rectangle is being created, at the first step, the x is assigned, but it's off-center, right? Because width is still 0. But when we assign to width a couple lines later, it actually the QML knows that there is another property referring to width, and it will again calculate the value of the property, and then the rectangle moves to the center, right? And this is not happening only during the start of the application. This is happening all the time, and we can make pretty nice use of that. So here we have again a blue rectangle, a text, and an animation. The property animation thing at the end is a non-visual element. So QtQuick doesn't have only rectangles and texts, but it also have non-visual elements that you really cannot see, but they have some functionality. In this case, property animation, we just said what we want to animate. So we animate the blue rectangle and the property width of the blue rectangle. We say we want to animate it from 200 to 600, so the width will just grow. And then for duration is 5 seconds, and then we just enable it, right? So yeah, that's what's happening, right? The animation is changing the width of the blue rectangle, so it's growing and it's looping again and again and again. What's interesting is that nowhere in the code is nothing like Well, normally in C or C++ or any other language, what you would do is you would have to have a callback connected to, I don't know, on width change or on geometry change signal, right? You would have to have a callback connected to it, and you would need to get the new width of the rectangle and then set it to the text, right? So that the text gets being updated. In QML, there's nothing like that, right? There is no callback, nothing involved. All the magic is in the text property of the text element, right? We say the text is equal to, math.floor of blue rect width. So math.floor is JavaScript, right? That's from JavaScript, right? JavaScript has this math library, so which is also available in QML, so you can use things like this, right? So it's a completely valid ECMA script. And yeah, QML is smart enough to know that even though the blue rectangle width is just an argument of the floor function, it still knows that it needs to evaluate the property every time the width changes and update the value of the text property. And this way, the text automatically updates itself, right? And this makes so many things so easy, right? Because you don't have to have any more like random connecting to a signal somewhere and then having a callback somewhere else, which changes, properties of this object somewhere else, right? You have the object, and then you see that this property of this object depends on exactly these things, which makes it really easy to navigate, right? It makes it really easy to fix and find bugs and change behaviors, right? Because you don't have to go and find all the places where this button is being disabled, right, in the code from some random callbacks. You just look at the button, you find this enabled property, and then you see the expression which says, disable it if this condition is true, or this condition is true, or this condition is true. So we just change it, fix it, and you know that nothing else would be affected the button, right? So it makes it really easy to fix the bugs. Actually, I have this more useful example. We are finally getting to actually showing some widgets here. So here I have a combo box, a checkbox, and 2 buttons, right? And the properties of the checkbox and the buttons somehow depend on the state of the combo box. So the checkbox will be checked if the first item in the combo box is selected. The first button will be enabled only if the second item in the combo box is selected, and the third button will be only visible if the third item in the combo box is selected. So this is something like you do often in your UI, right? You have parts of your UI enabled or hidden depending on some state of some checkbox or some combo box value, right? So if I go and switch it to item 2, as you would expect, the button is now enabled, the checkbox is unchecked, right? And there are no callbacks or signals or anything, right? I just set the condition, send the property of the button depends on some condition, and whenever that condition changes, then QML will reevaluate if the condition is true now, and then update the properties accordingly. So this makes it really simple to create UI. Right. Another great example how QML makes it easier for you to create UI. Here we want to create a bunch of radio buttons, or well, it could be any buttons or any other widgets, right? But in the code, we actually only had to mention it only once, right? We just say the radio button once, and we use a component called repeater. And then we pass some data to the repeater, and then the repeater instantiates the radio button for each item in the model. The model can be anything. In this case, it's a simple JavaScript array, with objects. It can be just a simple array of strings, array of numbers. It can be basically any JavaScript array. It can also be a QString, so a Qt container class, or it can even be a QAbstract item model derived class. So that's like the Qt base class for models, right? So it's very, very versatile. So you don't need to, if you have simple things like this, you don't have to implement like a complicated QAbstract item model subclass in C++ and import it. You are perfectly, okay with just some JavaScript array, right? But if we would get to something more complicated, then you maybe want to go to have a C++ model. Or you can do, with a model, actually this is for instance what the network management applet in KDE does. It has models implemented in C++, which talk to network manager, and they provide information about the available Wi-Fi networks and the strength of the signal and stuff like that. And then we just import these as a plugins or as a modules into the QML and attach them to a view. And then so we get the data fed to QML from C++, doing the complicated, talking over dbus with network manager. But the actual visualization happens in QML, where we have the list view and a bunch of delegates to actually visualize the items differently and so on. So yeah, that was more models. But here we have just a simple model. Well, and the QML, what it does is that for each of the item in the model, it just instantiates a new radio button, right? In this case. So here we have it. So I can even switch those. Yeah, there's a special property called model data, which is something called attach property. I will not go into that in detail, but it just makes the data of the current item available to each instance of the radio button, so that we get the title and the default checked state basically propagated from the model to the radio button to the delegate. Okay, that's it. That's the last slide. I decided to show you how easy QML is. I decided to take a risk and actually write some program here during the presentation. Actually, I will not write the program. I will show you how to create a simple QML calculator without actually writing any code. So I will sit down. I will try to close this. Right, so let's create a new project. We create a QtQuick controls project. We call it a calculator. Let's use new version of Qt. Yes, please. Okay. Wow, this is code. Code is ugly. Let's use something else.
Increase the font.
We don't need font. We will do it. Okay. We will not do it. Let's try again. That's better. Okay, so we have a window. Sorry, it's so small, but the screen is small. So let's create a calculator. So for a calculator, we will need a bunch of buttons, right? So come on, work. So let's have one button. This will be slow. So QML was created actually with non-developers in mind. So the idea is that you can actually have your designer or people from the design team actually have to come up with mockup instead of just creating mockups in, I don't know, whatever tools are used for mockups. I don't know, Photoshop, MS Paint, whatever. They can actually create a simple UI in QML, right? You don't really have to be a developer. You don't have to be a programmer to get the idea how to create QML. You just saw how simple it is. So you can have basically your design team or designers actually create a working mockup or working example or UI prototype in QML, just like this, right? And then so you can have these people create the UI and then just hand it over to developers who just bridge it with the C++ backend they wrote, and everyone is happy, right? The designers cannot complain that you made it 2 pixels wider than they wanted, and you don't have to bother with, stupid UI. So let's make this bigger. And let's make this fill the rectangle. Let's set some margins. Yep, that looks good. We want to get rid of the text. Now we label the buttons. Yeah, okay. I cannot really zoom this in, I'm sorry, but hopefully you get the idea what I'm doing. 9. This will be 0. This will be plus, minus, equals, and clear. Now we put it into some sort of layout so it doesn't break when we change the window size. So let's hit grid layout. And magic happened. Okay, cool. So now we have a UI. I can just run this. Yes, please. Okay, I need to compile it first. Done. Okay, so that's it. We have a UI, right? It took me 3 minutes, maybe less. Right, so we have a UI that works. I can actually click the buttons and everything. Now, how do we make it to actually do something? Go away. So I could switch to the code and start implementing the behavior in the code. But why would I do it? I can do it from here, right? So this says button 1. So that's the button I want to do something for. And there's a signal handler. So the button will, when I click it, the button will emit a clicked signal. And in QML, for each signal, you automatically get a handler called on something. So on clicked, on text changed, on whatever. So we connect to that. And the action we want to happen, I will do one more thing, and that is I will rename the label that shows the current result to result. And what I want to do when I click the button is that in case of the first button, I want to result.text just append 1. Right, so this is a super simple JavaScript expression, just append, we just append to the text property of the text label here, right? So we do this for each button. This might take a while. So on clicked, we append 2. For 3, we append 3. For plus, we actually append plus. So this is, this is a bit of programming, right? I don't really think this is real programming. Anyone can do this kind of, just writing simple expressions. They are actually quite intuitive. So even if you are a non-developer, you can still do this simple stuff. So yeah, it makes it possible to actually, with QML, you can just sit down with your fellow developers and you can quickly prototype some ideas for UI. And you can even get, the idea how it looks like and what it will do, right? Mockups and wireframes are fine, but the problem is that they are not moving, right? You don't see what's going to really happen when you click a button or when you just change something. While with QML, really doing stuff is so easy, and so you are done really fast. This will be 0. This will be so for the clear button. I will just instead of appending, I will just set the result text to empty string. And now for the equals button, I will just it went off screen. I will just do this is JavaScript, right? So I can use eval to evaluate the expression in a text field, right? And assign it back to the text field. So let's see, build and run. Hope I didn't do any typo. So let's see. How much is 42 minus 6? 6. Right. So I created a working calculator without actually writing any real code. And thank you. So yeah, so this is how easy it is to prototype or create something with QML, right? So I will not try to improve it because that's when things would go wrong. So I think I will end this talk. So if you have any questions. Yeah?
Which parts of KD Plasma desktop with QML?
The entire desktop. Like this whole thing is QML. There is obviously a lot of C++ backends involved in there, but the entire shell is in QML. Not the applications, but the shell as the desktop shell.
Applications also, but most of them are still in widgets.
Indeed. I can show you, for instance, the desktop settings dialog, which is like a settings dialog for the desktop. This is also completely QML UI. Right. And you can see the animations when it switches. You get it for free with QML because you just said, well, animate property, X or Y, and then it just instead of disappearing instantaneously, the animation just makes it slide away slowly, and it's like 5 lines of QML again, maybe less.
How much C++ code was written?
For the Plasma thing, quite a lot. There is the problem is that there are things that you cannot really do in QML, right? Handling multiple screen support. Getting access to files, so you need to have the file system access implemented in QML. And then there's a lot of logic involved, right? How wide the panel should be and everything. So yeah, but basically but this is the application logic, right? The actual UI is QML. Yeah. Yeah, that's. Yeah, that's true. For instance, the problem with the components is that the controls are really properly available on desktop. You can have them on phone as well. For instance, on Android, they work rather nice. But for instance, BlackBerry, they don't really have QtQuick controls. So the buttons I showed you just now, they have their own module that have their own components there. So if you are developing from Yola or BlackBerry, you instead of importing QtQuick controls, you import com.yola.something, and then you get the Yola components, which might have slightly different API, slightly different property names than the BlackBerry ones, and which might be slightly different than the QtQuick controls. So yeah, eventually, if you want to target all the mobile platforms with at once, you will have to have different UI for each platform. But then again, it's easy, right? Because your actual logic, the C++ code, you share on all platforms because that's in C++. And you just have different UI for different platforms, which is actually good because then you get native look on each platform, maybe adapted to the size of the device.
These QtQuick controls are also fairly new, so there is hope that people will also port it to the other platforms and do what they do also on the desktop platform, which is to emulate the look of the native controls.
Yeah, well, they are not new. They've been around for a couple of years, for quite a few years, but they've been rewritten like many times. But they support custom styles, so you can actually have your custom style library. So you can make your own. Basically, this is what you can see here, right? That we have not the default Qt looks, but we have the components here actually have a KDE Breeze theme, so they look differently.
What choices do I have if I don't want to use C++ as language for backend?
Right. So what choices? What else you can use except for C++ for backends? I've already mentioned that you have at least Python, Ruby, and Go bindings. I think I heard about Erlang bindings, Haskell bindings. So if you like obscure things, why not? I don't know what the state of these bindings is, but at least Python is definitely doable. You can write. There's PyQt, right? You can write the entire Qt applications with Python, and so this applies to writing a backend for QML code as well.
Is it fully supported? It has the same functionality and the same as C++, or the binding is a subset of possibilities?
Well, the bindings, first, the bindings are not officially developed by Qt, right? They are developed by other company. I think you don't get like 100% API compatibility. Like there are things that you cannot copy easily in Python, like templates. So there it is maybe slightly different, but the general stuff is like the API is 1-to-1. Yeah, that's.
Basically, it makes you range from QML directly to Python. You actually don't have access to all the C++ classes, but the communication with Python is asynchronous, and you actually start your QML application first, and then do asynchronous calls to Python, which is quite nice and doesn't slow down your application startup and stuff like this that normal bindings do. And for this repeater example, can you bring the slide up?
I think I need to restart. Yeah. Come on. I need to wait to jump to the last slide quickly. That's it. Yep.
So here you have checked is mobile data dot checked, and then if you but actually you can click on the option buttons, and their state will change. Does this write this back into the model, or how is this exactly
Right. Well, you wouldn't see it in the code, right? When I change the button, you wouldn't change the value in the code because the code is separated. I think that this doesn't happen, but we can take a look after the talk. I'm out of time, so let's check it after. Thank you.